considering that the limit of the expression 2x plus 3 as x approaches 1 equals 5, we're going to find the largest value of delta such that the function value, whatever 2x plus 3 is no more than 0.01, actually less than 0.01 units away from 5, whenever the x value is less than delta units away from 1. So we want the delta that we find to make this happen. So let's kind of start with that and see if we can express absolute value of x minus 1 in terms of a number that will work for us. So I like to begin with this expression, the absolute value of 2x plus 3 minus 5, and just kind of work on it a little bit, simplify it, see what it looks like. If we clear the parentheses and then subtract 5, it's going to look like this. Absolute value of 2x minus 2. And then if I'm going to throw in that extra step. I'm going to factor out the 2. Actually, it boils down to 2 extra steps. Not a big deal as long as the slope of that linear function is positive, but when the slope of the linear function is negative, sure don't want to go factoring out a negative 2. That doesn't make sense. And then there's the question about where the negative sign goes. So the absolute value of a product is equal to the product of the absolute values. Basically, I'm using the fact that the absolute value of AB is equal to the absolute value of A times the absolute value of B, whatever signs A and B might have. This is a true statement. So this is the absolute value of 2 times the absolute value of x minus 1, and then the absolute value of 2 is just 2. That's why we can factor out the 2, and it looks like that's what's happening. So this is 2 times the absolute value of x minus 1. Now, we want this expression to be less than 0.01. So we want absolute value, 2 times absolute value of x minus 1 to be less than 0.01. So it looks like that's going to happen when the absolute value of x minus 1 is less than what? Whatever 0.01 divided by 2 is. So absolute value of x minus 1 is less than 0.005. Okay, so it looks like delta equals 0.005 works. And by works, it simply means that whenever x is within 0.005 units of 1, then f of x, 2x plus 3, is within 0.01 units of 5. Now, show it works. No, the homework problem didn't say show it works. It just said find the delta. But if we find it, we want to be confident that it actually does work. So to show it works, it looks a lot like what we just did. It's going to feel like deja vu, but really what we did is just kind of scratch work. Now we actually want to show that it works. Suppose 0 is less than the absolute value of x minus 1, and that's less than 0.005. Let's just make this assumption. We want to show this. We want to show that based on this assumption, as long as x is where it needs to be, 2x plus 3 minus 5 has absolute value less than 0.01. Sorry. So let's show it by beginning with the expression and then demonstrating that in fact this is less than 0.01. So I don't want a less than sign there, sorry. I apologize if you're using pen. I want an equal sign there. So kind of just what we did, but I'm going to skip a couple steps so it doesn't seem quite so tedious. This equals the absolute value of 2x minus 2. based on what we did over here, this equals 2 times the absolute value of x minus 1. Now, we're assuming this right here. So we've got to use that. If we don't use that, then what we're concluding would be always true. It's not always true, but it is going to be true if absolute value of x minus 1 is less than 0.005. So we've got to use this. If this is true, so off to the side, maybe over here, absolute value of x minus 1 is less than 0.005. What happens when we multiply both sides by 2?
Or 0.
Yeah, there we go, like that. So if we have this expression here, based on our assumption, this is less than 2 times 0.005, and that's equal to 0.01. So sure enough, absolute value of 2x plus 3 minus 5 is less than 0.001. And that concludes that.